So in this problem, we have a 0.1 molar solution of a weak acid and the pH is 4.2. From that we can calculate what the Ka is, or the dissociation constant is. The Ka basically tells us the ratio of how much of it dissociates versus how much of it stays together. So if you have a relatively large value for Ka, like a positive exponent, that would be a strong acid. If you have a weak acid, they're usually classified as having a Ka of 10 to the negative third or less. So, before we do anything with the Ka, first thing we need to do is find out the hydronium ion concentration for the solution. And since we were given the pH to be 4.2, we can use this equation, which states that the hydronium ion concentration is 10 to the negative pH. We did that, and we found the concentration to be 6.31 times 10 to the negative fifth molar. Alright. So, when setting up an ice chart, the I stands for the initial amount present in the solution. We're assuming that all of it starts as the weak acid, and none of it has yet dissociated into the hydronium ion or the conjugate base. Then it's going to undergo change as it reaches equilibrium. So, we know how much the H plus or hydronium ion concentration is going to get to, so it's pretty easy to calculate the change from 0 to that amount. Now, for every H plus or hydronium ion generated, you also produce its conjugate base of this weak acid. So, these values should be the same. Now, in this case, when you take away the amount that had to get used up to make those, the hydronium ion and the conjugate base, it makes almost no difference in the concentration of the weak acid, as most of it clearly stays this way. So we can say that it's approximately the same. So when we plug in these values to calculate the Ka, the hydronium ion concentration times the conjugate base concentration, divided by the equilibrium concentration. Now I know they're the same, but we're using the equilibrium concentrations of all of these. You plug that in, you get the Ka is equal to 4.0 times 10 to the negative 8, which is a very weak base. Done.